Hello and welcome to this screencast on sets and set operations. So I'm going to go straight ahead and start by drawing what's called a Venn diagram. A Venn diagram is simply a pictorial representation of sets and set operations. So I start by drawing a rectangle, and what I've done in a rectangle, I've drawn the U for the universal set. So everything contained in this rectangle is in the universal set. And I'm just going to draw two closed curves, and these closed curves represents the sets A and B. Okay, so I'm going to start by talking about set union, and set union of two sets A and B is denoted by this cup shape. Okay, this cup shape symbol here, this is a union symbol. Okay, and union of sets A and B means all the elements in A together with all the elements in B. So on my Venn diagram, what I'm going to do is I'm just going to shade, okay, the circle or the closed loop representing set A. And so this shaded region contains all the elements in set A, and A union B will also include those elements in B. So I'm going to shade the set B. Okay, so the union of two sets A and B is denoted by this U shape symbol, and it contains all the elements in A together with all the elements in B. Okay, that's the first set operation we're going to look at. The second one is called intersection. So I'm going to start by drawing another Venn diagram. Again, two sets A and B. So I've got closed curves representing my sets A and B. Okay, and don't forget the universal symbol in the corner. Okay, so intersection, just spell it here. This intersection between two sets A and B is denoted by a cap B. Okay, so this cap shape here, just the union symbol upside down really, and this means all the elements in A and B. Okay, so A intersection B is basically any element which is in A and in B. And so this is quite simply the overlapping region. So for an element to be in A intersection B, it must be in this overlapping region here. Okay, so that's union, and we also have intersection. Okay, so I just need to scroll down a bit and talk about two further examples of set operations. I'm going to look at set complement. Okay, so again, another Venn diagram, and this time I'm only interested in one set. Okay, so again I have a basic Venn diagram, and this time I'm just interested in set A. So we're going to look at complement now. Okay, and the complement of a set A is denoted by A prime or A dash. And basically this contains all the elements which aren't in A. So what I'm going to do is I'm going to shade all the region outside of my set A. Okay. So anything not in A, so any element within our universal set which isn't in my set A is a member of A complement. So that's a complement of a set. And the last one I'm going to look at in today's podcast is the idea of set difference. Okay, so just scroll down. So final Venn diagram. Okay, so this time I need two sets, set A and set B. Again, so my general Venn diagram, and that's with the universal set. Okay, so the idea of set difference is sort of like subtraction, not quite. So set difference is represented by A backslash B, and this means we have all the elements in A that aren't in B. Okay, so another way of writing set difference is A intersection B complement. Okay, so I'm looking for all the elements in A that aren't in B. So what I do is I shade my set A, but I don't shade anything which is in set B. So I don't shade the overlapping region. and that is set difference. Okay, so we have four, or we've looked at four set operations. So if I just scroll back up to have a look at the first one, so we've looked at a set union, which is all the elements in A together with the elements in B. We have set intersection, which is the elements in A and B. We have the complement of a set, which is all the elements which aren't in the set, for example, A. And finally, we have set difference, which is all the elements in A but not in set B. Okay, so that's the four basic set operations, and we're happy now because we know what they mean.